Hi everyone, my name is Mohammed Ali Tawfiq. I'm from Management Science University. Together with Nurul Fazila Zainuddin and Ahmed Fadila has been my teammate. We will do presentation in 17 IEEE on signal processing and its application. The title of the paper will be Mitigation of the Harmonic Distortion for Grid-Connected PV Solar using MPPT controller. First of all, we will talk about the introduction. The increase in the demand for efficiency and reliable sources of the power distribution from the consumer are caused by paradigm shift in power generation for the years, which led to some challenges like the high cost of establishing a new site for the power plant and the restriction on the transmission lines that had been built years earlier. That led to a new concept proposed in early 80s known as distributed generation. The DG unit will continue to provide the power to respectively connected line, which led to an islands formation. The fast Fourier transform (FFT) method will analyze the total harmonic distortion of the system. This paper's main objectives are mitigation of one of the power quality issues, which is the harmonic distortion in distributed generation DG system, which focuses on the harmonic distortion, the sinusoidal waveform that is produced by each component in DG grid network. We use the system modeling with design of the by MATLAB Simuli for this distributed generation. First step, we need to know what is the harmonic distortion. The harmonic distortion is a measurement of the harmonic distortion present in a signal and is defined as ratio of the sum of the power to all the harmonics components to the power of fundamental frequency. What are its effects? The harmonic currents produced by non-linear loads are injected back into the supply systems. This current can interact adversely with a wide range of the power system equipment, most notably capacitors, transformers, and motors, causing the additional losses, overheating, and overloading. So design a PV grid connected. So this section clarifies the methodology, components utilized as a part of this project, and the MATLAB model design in the simulator. Choosing the proper and suitable method has to be made to make sure the project running aligned with the objective and scopes. So therefore, the maximum power point tracking MPPT method is used for this project to further observe, investigate, and analyze the signal produced by PV array as a DG in terms of the voltage, current, irradiance, and PV mean value as well as the power being produced on the grid and corresponding voltage and current as well. So you can see here we have DG grid connected. As you can see, the left side we have DG, which is connected to the inverter base, and also we have the PCC. This node is a PCC, point of common coupling, and also we have the circuit breaker, and then it's connected to the utility grid. So the PV solar grid connected system, as you can see here, this is a model from the MATLAB Simuli. Okay, we design, as you can see here, the PV array, and we have MPPT controller here, which is connected to the boost converter. Okay, and then the power system, and connected to utility grid as well. So the equation below shows the current characteristic of the PV cell, which can be expressed as IPV is equal to IPH minus IO exponential VPV plus RSE IPV over VTH minus 1. So where the IPH is a light generated current, IO will be reverse saturation current of the PV array. RSE is of course is a series resistance, and VTH is thermal voltage as well. So this is a waveform for PV array waveform. So you can see how it looks like when we run the PV. So the method proposed are used to analyze the data on the signal and further proceed with the analysis of the total harmonic distortion THD from the fast Fourier transform FFT method. So you can see at the top, as you can see here, the output power of the power grid, and at the bottom you can see the mitigation of the harmonics and from the FFT. So fast Fourier transformation analysis for irradiance signal. You can see the waveform here. And looks like. So the conclusion, the total harmonic distortion of the signal varies depending on the voltage and current flow in the system, which the system is having a constant value of the frequency. The PV array in this project is set under a controlled environment. The increment of the THD will affect the power quality issues, although not by a large margin. The THD difference of the power output is still in acceptable range, which is a 5% margin of this project, showing exemplary power quality. So here there is a references for this paper. If you have any questions for more details of this project, this paper, please contact alitofir@ieee.org. Thank you very much for attention and listening to this presentation. Have a nice, great.